All right, we've started the recording.
Okay, so we're the risk meeting. It's October 8th, 2025. Just kidding. It's 2020.
Close.
If you enable screen sharing for me, I can put the minutes up.
Can do. There you go.
All right. Oops. And here we go. We're off. And so the things that, oh, yes, moving to the LF hosted Zoom November 1st. And is there like a standard link like you have for yours, Matt, where it's always the same room, or are we going to
Yeah, we'll set up just a recurring meeting.
Okay.
And it's all good to go, but we're just kind of giving some lead time for November 1st.
Okay, so there will be a new link.
Yep, and we'll do all the updates to this sheet and to the mail list and to the participate page and to the so whatever else.
All right, good. So thank you. I was jumping into the dependency tracking spreadsheet only because when it comes to tagging updates without Kate here, the one cool thing that I learned about this Mariner project is they have, it sounded like 6 different issue tags that they're using to identify friendliness.
So this is from Dwayne O'Brien at Indeed, and they were using kind of an internal tool to build their dependency list. And from that list, they were using this tool called Mariner, which would look at the dependencies, and within those dependencies determine if any of the dependency software had issues that had one of 6 particular issues, or any of the 6 particular issues, like good first issue, or I don't know, maybe Hacktoberfest for this time of year, right? And so the idea was that you could identify kind of easy to solve issues on your dependencies and be a good corporate steward on those dependencies and kind of help maintain that ecosystem. So that's what Mariner is.
And it looks like their configuration file is basically organization/person.
Hi, Sophia.
Or set hey, Sophia. Organization/repository. I don't know what these numbers mean.
I think it's a weighting score, but I don't think it means anything at the moment.
Okay.
So Sophia, we're looking at there's a
roll back the dice here, rolling back to tags.
Did you bring up Mariner in the weekly? So I looked at it at the meeting, but it looks really promising.
So what I'm trying to do here in this spreadsheet is, based on the conversations that we've been having around dependencies, is try to just kind of get a lay of the land of what's going on with dependencies. And
yeah, this is
thanks, David.
There's a huge, I added one, but I think the thing is, this is actually a big job. You don't realize it yet. There's a whole bunch of these.
I just started like 30 minutes ago, so this is not. I'm like, oh, I should do something. But the interesting thing is that I didn't find a lot of tooling out there that actually created the dependency trees. A lot of the tools do something with the dependency trees,
but actually visualize what the dependencies are upstream and downstream.
Yeah. So I could use a little help there if people know of open source tooling that does that in any ecosystem. It doesn't matter particularly. So like I said, there are a lot of tools that do things with the output, but not necessarily create the output. I didn't look very deeply at a lot of these.
Yeah, so there's let's see.
So this looks like a fairly fresh project that you shared at Reactive Circuits, David.
What,
You want to put
fairly
that?
fresh? I mean, this thing's been around for what, 10 years?
Oh, has it? Reactive Circuits release probe?
No, not reactive circuit. I didn't add that one. I
Okay.
added dependency check.
Okay.
Yeah, what's weird, dependency check and dependency track are easily confused. They have very similar names. They're both from OWASP. They both involve supply chain, software composition analysis. And so I have a hard time keeping track of which is which. And so I can't be the only one.
Yeah, yeah.
Now, I mean, I don't know how you want to do this, because a whole lot of tools, like many package managers include something which analyzes their own dependencies and does stuff.
Yep.
So I mean, I can mention a couple just that I know offhand. I mean, bundler audit, for example. But I mean, I don't. At what point do we want to? Oh my goodness.
So this is where going to multiple working groups can be useful.
Part of this exercise is because dependencies have such a big impact in a variety of different working groups.
Yeah.
I think we've kind of been talking about the creation of dependency maps or dependencies in these kind of vague terms, and we need some rooting to be done. And so go ahead.
Yeah, so this spreadsheet I'm sharing is what the evolution working group came up with as the categories of dependency to look for.
Yeah, so for example, let's see here, tooling. Interesting. I thought the SPDX folks would just have a nice big list for me, and they don't. Shame on you guys.
I think their next release is largely about dependencies.
Well, I mean, to be fair, actually, their current one has quite a bit, but and NTIA has, I mean, this is a whole, I'm a little afraid to go down this path because it's a big path.
Yeah. So
and frankly, if we're going to go there, I would want I would want to arrange to do this only once. There's actually OpenSSF is supposed to be doing. It has a tooling group, and I've been seriously wondering about proposing. I don't know if you've ever seen the landscaping tools, like for CNCF. Have you seen any of those?
Yeah, I think Kate has shared some of those with us.
Yeah. So I mean, tools for security.
Oops.
Yeah, tools for security. Oh, sorry, go ahead.
Is it the project maturity where they're incubating or not incubating?
No, although they might include that too. So let's see here. I mean, landscape. Let's try landscapecncf.io. I think that would be a pretty mature model example of that. Go to landscape.cncf.io. And you can blame Dan Kahn for this stuff.
Yep, I've clearly been here before because yes, we've looked at this.
Right. The advantage of this is this all based on a YAML file. So all you have to do is go into GitHub, edit a YAML file, and poof, you've got new stuff on there. Of course, the big trick. Sorry.
That's a priori, where you're not detecting dependencies that are hidden. You're declaring dependencies.
Wait. I wouldn't use this to declare like dependencies of individual projects. I would use this for identifying what tools are out there that can analyze dependencies or do other kinds of security analysis. The reason I mention this is that the OpenSSF group has a tooling group, and I'm seriously thinking, I have not raised this yet, but I'm seriously thinking about proposing that they create something like this.
This is
and
so
then
big.
One of those would be for software for SCA kinds of work.
Can Matt and do you all have big enough screens to see what I'm sharing right now?
Yep, sure do.
I've seen this before too. So
yeah, we've talked about it in the meeting, but I guess I don't know what I'm looking for.
Well, it just is, No, the idea here would be, I mean, there's nothing wrong with trying to make this little spreadsheet in the short term. But if the real goal here is, hey, we want to identify the tools, it might be better to get a group whose job is to do tooling related things and say, here's a start. You go edit and basically make somebody else do the hard work.
Well, I mean, if this,
so,
go ahead, Sean.
I mean, I think observability and analysis tools, this is, I think, the category that what we're talking about would be in, like dependency.
I don't know what observability analysis is, but I do know what
observability and analysis. This looks like infrastructure.
You're talking about the CNCF.
Yeah.
Okay, yeah. I wouldn't worry about the details of this particular. Okay. It's just, hey, you can organize things so that you can structure grouping and categories, and like have some shaded and some not, say if they're open source, and then let somebody else, by all means, create a starter list of some of the tools and such that exist. I don't want to dissuade you from that, but it might in the long term be something that you might be able to get some other group to do. As I said, I haven't proposed that yet, but it's
sure, and that's fine.
Things so I might be able to do.
The long arc here is in the CHAOSS project when we develop metrics to solve a particular problem or to be aimed at a particular question. We don't want those what's that?
Bring light somewhere.
Right.
We don't want those metrics to simply just live in space by themselves. And so the idea here is that we need to start understanding the landscape of dependency tooling so that if somebody wants to deploy a particular metric, we need to start getting our head around where that metric can even be deployed, or if it can't be deployed, what are the tools that we should be contributing to get this metric deployable. So I'm not suggesting that we're going to necessarily create the tools, but I think we need to get a better handle on what exists and where our metrics could actually be deployed.
Right. And I guess, I have particular interests in measurements of things like, are there components with known vulnerabilities in them, and are there vulnerabilities and are they exploitable?
Yep,
I'm sure there are other ways. I'm sure there are other ways to measure it, but in my mind, at least I'm looking at this very much from a security perspective, and I think from a risks perspective, that's not dissimilar.
No, that's totally spot on. So then in that case, if we develop metrics kind of per what you're talking about, where should we be pointing people tooling wise to even think about getting this type of information? Because like obviously deps.cloud is not going to answer every dependency question, and Mariner's not going to answer every dependency question, but they might answer some of them.
Right. But I think that's very much a reasonable goal is, are there tools or a collection of tools that can together answer that question?
Yep.
How many, what percentage, how old, how long have those been vulnerable? And I will say a complication of this, and I people have been talking about this for quite some time, is, just because a component's in there does not mean it's actually vulnerable. For a variety of reasons. The most obvious one is, the component's in there, but it's not accessible in that way. That part of that code is never used. So there's no, yes, even though that code has a vulnerability, but there's no way that it could be exploited in its given environment. A second problem is that version numbers often lie. So for example, if you see a package in Red Hat and it says x.y.c, that may not be vulnerable to the same vulnerability that component XYZ is, because Red Hat occasionally backpatches.
So maybe a better way to kind of structure this would be around scenarios. For example, this spreadsheet is what I'm talking about with this. So in this example, listening to Talk David, if somebody wanted to get a better understanding of the vulnerabilities associated with the dependencies for a particular project.
Right.
Great. And so then the question becomes, what would be the tool chain or the tool set that somebody would need to make that understanding a reality? And that's a different tool set than, say, in the case of Mariner, if I wanted to understand kind of low-hanging issues in my dependency tree, then I would use, say, deps.cloud and Mariner. I would use kind of this sequence of tooling.
What is
Go ahead, Sophia.
Go ahead, Sophia.
I'm thinking your comment that a lot of these tools are just spitting out a number. They're not actually showing you the, say, dependency graph that's the data behind the number. So they're more specific to a specific use case in terms of, say, if you want this metric, you can use this tool to give you this number. But that isn't necessarily going to solve all of your dependency analysis trouble. And I feel like this is where the break is for me, in that my mind initially goes to, well, what we really need is some sort of graph analysis tool. Because a lot of, say, you want to visualize your dependency, and if you give a visual of it, it will show you where your hotspots are. And just sort of, and that is the data architecture below what we're looking at from a dependency standpoint, and that will give you more flexibility over the types of counts and algorithms you can run over that. So
yeah, I think you want some graph analysis, perhaps. Although, really, I think you'd be surprised how simple these graphs, the analysis is. But I actually am not convinced that you want the visualization. I actually, I maintain the best practice. Just to let you know some specific experiences. I maintain the best practices badge app. It's a simple Ruby on Rails app. It only has 200 gems in it, which is very, very small by the standards of that ecosystem. And I have a visualization tool, and I can't understand the graph result. What it shows me is a crazy number of things and their interdependencies. And already at a very small scale, it's too hard to understand. When you hit 30 or 40,000 libraries, the graphs are not really, I'm glad that we can do the graphs. I don't know that they'll actually provide useful information.
I think from the perspective of, I agree with you, having done large scale graph analysis of social networks, but I think what Sophia's point is, it's still a really good point. Like, if I'm thinking about my project, like if I'm thinking about Augur and I want to understand its dependencies, I think the graph is tractable. And it would be easier for me to understand, like, if there's red stuff that says I've got security vulnerabilities in this dependency, for example, the visual of that would be very helpful, because when I collect all these different kinds of dependencies, which would be ultimately the goal,
yeah,
there's a lot to unpack there. So, like, I wouldn't want to do it for I wouldn't want to do a graph for a whole ecosystem necessarily, but
even for a particular program. It's quite, I mean, now, and you mentioned people as an interesting point. I doubt very much you normally look at a graph of all the people. You want to find a small subset, because the big graph is unhandleable.
It is. I think that the thing that I was thinking about, which is, I guess, which makes it difficult, is just dimensionality of it. And most metrics, you're trying to put in sort of a two-dimensional number of something, and I guess not exactly when you're thinking about graphs. I guess now we're too many graph topics here, but when I'm thinking about an actual graph in terms of network analysis that allows you to look at, say, something like the number of dependencies at different focal points. So if you're looking at your project is, I mean, maybe it could be one giant mono repo with a million arms, but most likely there are pockets. And so when you're looking at, say, dependencies around individual pockets, something like a network analysis tool can allow you to click into different levels. So you're actually now flipping it into a third dimension where you're looking at points of analysis on multiple areas. So I think for me, I guess the draw to some sort of visual tool allows you to see that there is, in fact, when you're looking at one metric, it's not one metric, it potentially is you are applying that metric at multiple points in your project or multiple centers in your project. I'm talking about it very abstractly. So I guess in practicality, to your point, when this gets large enough, like the headache that I'm going through right now with dealing with Kubernetes data is like, I don't want to subject that to anyone. We're clearly not going to do it for that project because it's just too big. But actually did find a Kubernetes dependency map that someone did internally that I'm not allowed to share, and it is frightening looking. So I understand that is a challenge. I guess for me, when I'm thinking about it in the metrics application, I'm trying to how do we reconcile the fact that these metrics aren't going to be at a single point in time and might be more applicable to various points within a project.
I have two questions for you, Sophia. So in the example that you're giving, is the output that's being used or the data that's being used to generate the graph, like the dependency data, how is that created?
And that's the part I don't know.
Okay.
I'm looking at tools. Your initial question was on tools. There are tools that do this. There are proprietary and open source tools where you can.
Which are the open source ones?
I just have one that I've never heard of called Gephi, or Gephi. Do you use that?
Gephi. Yep, that's a graph analysis
The ones that
tool.
I've used have been proprietary network analysis tools or service architecture mapping tools. Like I guess like something like Istio kind of does that, but it's very limited and very focused on service architecture. That's not.
But doesn't Guppy take a look at the output data of a dependency JSON or whatever the format might be? So like there has to be some tool that produces
like
some
D3 has
file.
a JavaScript network library that you can use.
So it's almost like there's two steps here. One is we have to first create the dependencies, irrespective of how we visualize them or irrespective of what metrics we put on them. Step number one. And then step number two is obviously then how do we visualize this data and with which metrics? And a lot of the things that I was seeing, there are not a lot of open source tools that do that first part, that actually just create the dependencies. And to David's point, there are package managers that will do it, and the steps.cloud tool can do it. But I think it's just working with a lot of the package managers, to be honest with you.
Yeah, it's nodes and edges, right? And ultimately on any system like I'm looking at, like Kubernetes is a node, and its dependencies in this case are the lines that we draw between it and other software that it relies on. And the network is then sort of measurable through how deep does that tree go? You know, how far down the rabbit hole do you walk back?
Would you mind if I shared my screen for a moment?
No. Let me just figure out how to stop sharing.
I'll set you up to do that here, David. Hold on just a second.
All right.
I see where you're kind of going with that, Sean, and because I was also thinking about it from the perspective if we are able to use at least a graph as the underlying topology, then you can also leverage those kinds of the math that applies to it.
Yeah.
In terms of how many steps you have, the actual connection point, then you can set values around it or directional attributes of it, and then.
I'm sorry. Go ahead. I'm sorry. I thought you were done. My apologies.
Sophie, have you seen the Panama Papers?
I have not.
So
I have.
There's
I've read about them anyway.
The Panama Papers. There's a network analysis that David, I'll let you share what you're doing here, but
okay.
What's it called?
Go ahead and finish your thought though.
I'm trying to remember there's one graph library tool, Neo4j.
Mm-hmm.
It's like a Neo4j back graph database engine. So they graphed what they ended up calling the Paradise Papers. This is from several years ago.
Yeah.
I'll put this link in the minutes. But there's an actual application in this post that I'll share in the minutes that lets you navigate the graph of, basically it's the interlocking directorate theory brought to life.
Yeah, so I just wanted to point out, I mean, I often, by the way, I totally understand the problem of what does the word graph mean. So I often say node and arc graphs just to clarify them as opposed to the XY graphs. So, you know, I certainly, I don't think about a lot of these things in terms of node and arc graphs, but just to give you an idea, in the best practices badge, we early on built in, there's actually tools that'll automatically take the dependencies of just, and this is just of the Ruby code. There's a little JavaScript code that's not included in this, um, and generates automatically a graph. And the problem that we found is that if you all you do is generate a graph, what you get is this kind of stuff. I can tell you what each of these is. Each of these is because I'm familiar with this particular program. But oh my gosh, this is very, very hard to deal with. It's just an overwhelming amount of data. And this is for a program specifically designed to be small. You know, it only has 200 libraries it depends on, which is a pittance for a lot of projects, which, you know, measure maybe, you know, at least 1,000 and possibly tens of thousands. If you yank in anything with React, I don't think you can. I think our empty React application is something like 600 libraries. That
This is
assumes it doesn't do anything.
this isn't David. This is an unfiltered graph, right? It's just kind of
That's right.
the.
But this is my point, though. An unfiltered graph is overwhelming. And so then you need more than just a, oh, I have a graph. You need to do what Sean was mentioning earlier. You need tools to help you move around and filter and figure it out and so on. Otherwise, even things you might think are small are overwhelming. This is one of the advantages of numbers. If you can boil things down to simple numbers or an XY graph, you no longer are overwhelmed. Now, I agree with you. If you can, you know, if you need to do the analysis and start walking around the graph, well, you can't do better than walking around the graph. But it becomes a whole new analysis challenge when you try to analyze these things. So,
David, how did you create the data that created this graph?
well, funny you should ask, because in fact I've got my commands up here earlier. What I did is I run it ran rake bundle viz, which actually, here we go. Bundle viz. Okay, bundle is the typical package manager for Ruby, and viz is a plugin that visualizes using graph viz all the nodes and arcs. And where does it get that data from? Just like Python and just like JavaScript, there's a convention for package managers. In the case of Ruby, there's something called a gem file, which lists all the direct dependencies. And then there's a gem file and then that generates something called a gemfile.lock, which lists all of the libraries and their transitive dependencies. And so fundamentally, it takes this data of transitive dependencies, which it has to have anyway in order to load things, and turns it into a graph.
Okay.
And a lot of package managers nowadays can do this kind of thing. It'll be different with Node. It'll be different with PyPy, but you know. I think, well, in some of these, like Python, oftentimes people don't record dependencies. That's the bigger problem. But if you track your dependencies using a tool designed for tracking dependencies, it's not so bad. But visualizing the data is still rough.
So at this point, I know it's just early in this discussion. Do you think it's a fair statement if the recommendation was, you know, how do you get a better handle on particular metrics within your dependency tree? The way to initially collect that data is really just through your package managers.
I think where possible, yes.
Okay.
Now, in my previous life, when what I would tell people is, please use a package manager. If you are copying code in with copy paste, or you know, download and just you know, install it into your source tree and forking everything,
Yep.
There are actually tools that will do that. Sonatype will be happy to sell you a tool that actually can manage to find out where your code comes from.
Yep.
Let's see, the last I checked, you need to have 256 gigabytes of RAM and and have a nice beefy machine and let it run for many hours, because the analysis you're asking it to do is actually very hard. Oh, by the way, it's not cheap. That tool, it both is expensive in hardware and expensive in cost because it's trying to do a hard job. If you decide to make your life easy by, well, why don't you use a package manager? I hear that some exist now. Life is easier, but you still need to do the analysis.
Okay.
You now have made the analysis. You've now made your data much more accessible, and I think for most projects, that's the better way to go, instead of trying to use a beefy tool to overcome the lack of that.
But I also think what you mentioned, so knowing that each project kind of, this is how Ruby has approached this problem, and
Yeah.
so maybe some of the guidance or metric is also, do you have the ability to do this? Because this is the baseline
Right.
that you need in order to run the network analysis. It's not just like use some crazy tool. It's you actually need to put this together in an accessible format. Here's an example where
Right.
it's just a file that you can upload.
Right, right. And I think that's actually I actually think that's, that's the unstated metric. You're absolutely right. That needs to be the stated metric. Step one, are you using appropriate package managers for your circumstance? And C doesn't have a standard package manager, but there are usually a system level package manager you can use. Well, go use that. But so I think, Sophia, you're exactly right. Step one, measure that. Are you using these tools to handle it automatically? Then the next step is, given the data sets, and I like the node and arcs for some purposes, but because it's overwhelming, I would much rather find simpler ways to express, like, how many components are, how many components do you use have at least one publicly known vulnerability? Now, not all of them may be exploitable, but at least, do they have vulnerabilities? The second step, which is way harder and requires analysis, is how many of them are exploitable, and that really requires real analysis and can be hard to do. But I'm sure there's other metrics, but those seem like and you're right. I hadn't thought about measuring the first one, but yes. I've been advocating it. I hadn't advocated measuring it. I'm going to change that now.
This is really helpful. Thank you. I have one question on package managers for you. The output from the package managers, how widely variable is it?
I don't know
The
what
dependency,
okay.
output, the dependency output. So
Okay, very much depends on the package manager, and some of them have plugins, and so you then have to ask using what. Let me talk about Ruby, because that's where we started. Ruby's actually one of the better ones in this way, in the sense that there's two files. This is actually one of the easier ones to understand too. There's basically two files: a gem file, which is essentially your input. What are my direct dependencies? And you can specify the specific version numbers. Then there's a program that takes that and generates the transitive closure. What are all the things you depend on, including the dependencies of the dependencies of the dependencies of the dependencies, and it identifies the specific version numbers for each of them.
Does it walk all the way to the end of each branch? Or
That's right.
Does it stop at a depth? Okay, it goes all the way to the end.
It has to go all the way, because this is necessary in order to be able to figure out what to load.
Yeah, I mean, conceptually, I definitely grasp that conceptually.
Yeah, I mean, if it loops, then there's a different issue. But but you essentially you've stopped at that point. Now, Ruby is like most programming languages. You can only load a particular version of a library. The same is more or less true of Python. The one language system where that's not really true is JavaScript's Node, where you can have arbitrary numbers of versions. of a particular library, all loaded in. And both designs have their pros and cons.
Yeah, I mean, in Python, you can, but you don't have to declare a version.
Well, but the thing is, let's say that, I mean, I won't say you can't. It is more challenging. You could in Python or Ruby load multiple versions of a library, but
Yeah,
it's generally going to be complicated. If you say import blah in
right.
Python, you
Yeah,
will import the
right.
version
No,
that's
okay.
accessible.
Yeah, no, I see. I understand what you're saying there.
Yeah.
It's the multiple versions of the same dependency is
Right.
not something I've done in Python. So
Yeah, you can do it in Python. You can do it in Ruby. It requires some self-brain surgery.
Yeah.
Not recommended. Whereas in JavaScript, that's the normal case. If you do an import, you do a locked import of that version, and if somebody else imports JavaScript, it's of that library, probably not the same version. In which case, now you have two versions, which can be fun if you wanted to minimize the amount of JavaScript being sent down.
Yeah, I
Helpful,
mean,
thank you.
so
Yeah, so anyway, I thought that might be a useful example of why just showing a node and graph of all your dependencies gets insane quickly. I've done that.
yeah, I mean, when I think about a system of any scale, like there's probably multiple. I mean, I don't know. Is a package manager? I mean, I don't trust intuitively that the package managers have enough information for me to say these are my dependencies.
I would
I think
agree with you and go further,
right.
which is no. The package manager is a program. If it's garbage in, garbage out. However, what you do is you make sure that it only has visibility of the libraries that you declared. So if you forgot to declare something, the program fails to run. Done.
Yeah.
So that's I mean now there's limitations of that. If it's a system level package manager, that becomes more problematic. But it is still possible to do that.
Yeah.
But for the language level package managers, usually this is pretty easily. Usually there's some sort of virtual environment system where you only have visibility of the libraries you declare. And if you don't declare them, that's the end of that story. And that makes it very, very easy to determine whether or not you can trust it. It's trusted in the sense that it won't run without it.
Mm-hmm.
Now, there is the reverse. I mean, you could declare a dependency and you don't ever use it. As far as problems go, that's not so bad. That would actually be yet another example of I brought in this library. It has a vulnerability, but it doesn't infect me because I don't use it in the way that the vulnerability. And boy, is that hard to. Those are hard. I don't have. People are talking about how to resolve that, and that just troublesome.
Taking some notes here. Based on what you said, I think when you talk about unused dependencies, I think that's a runtime problem. Like for a programmer, they probably don't care. But at the time of deployment, that's where the unused dependencies perhaps can be more problematic.
Yeah, I think the bigger issue. I mean, there's some space usage. Usually, that's not such a big deal. The bigger issue is, oh my gosh, hair on fire, big vulnerability. Well, no, not really.
Yeah, that's right. I agree with that.
Okay, so then based on some assumption that there's data available from which to create a visual or a graph or something.
Or at least some information. I mean, even if it's just here's the number or the percentage that are old or vulnerable and maybe how long they've been there. Yeah, actually, there's another thing. How long? That's actually very important too.
How long? Tell me what you mean. Like, how old is the release I'm using?
Well, how old is the release or how old is the vulnerability? It's probably not fair to beat on somebody because the vulnerability was announced an hour ago. But if they haven't fixed it in a week or a month or a year, maybe that's worth complaining about.
So the things that you're describing, David,
Yeah,
are
I'm thinking out loud about how to measure
yeah,
this.
yeah. So if let's say that there was a metric that was developed around the age of a vulnerability, right? That's something that you might want to take a look at. That might be a filter
Right.
that you would like to apply.
That's right. And severity of vulnerability too. That's
Sure.
something else probably should mention. You know, what's the
So I mean, up a little bit higher. I think security vulnerabilities are one application of the dependency graph. Another is sustainability issues. Do I have something that I depend on that hasn't been maintained or isn't being maintained any longer?
right?
That's another case where knowing my dependencies is valuable. I'm sure there are more.
Yes, licenses is off historically when people did dependency analysis. That's usually what they were caring about. Is in particular when in an M&A threat. What is it?
M&A mergers and acquisitions.
Thank you. I couldn't remember what the expansion. After a while, you only remember the acronym. You can't remember what the expansion is anymore. Thank you. Yeah, and in M&A, usually the first question was, well, I'm buying your product. I'm buying up your company for your product. Is it legal to distribute? So, you know, are the licenses valid? You know, do you have licenses for them all? Are you using them in a valid way?
So one of the on finishing this thought. So as there's kind of metrics that would be good to see from a risk perspective. Then the next question for me is, this is kind of that sheet, what tooling is available to provide that information? So this is that, we don't want to just develop metrics. I mean, if they're metrics that don't have tooling, that's fine. But then we have
But
to
you
think
want to know
about,
that, right?
yeah, I want to know that. And like, this is work to be done. So
Right.
then it's kind of that next step.
Okay, so have we, so I can tell you a little bit of the situation on some of this. It's not perfect, as you can probably imagine. Vulnerabilities themselves, by far and away, the most commonly used way to publicly identified vulnerabilities are CVEs, and you probably know about these. CVEs are tracked among other organizations by the National Vulnerability Database, the NVD. So I don't know if you wanted me to type on this, but
yeah, it's all are welcome to type.
Let's see.
On our
I have
paint
so
our
many
wall.
stinking. Yeah, I'm sorry. I have so many stinking tabs open now. I'm starting to lose the bubble here. Sorry about
Honestly,
that.
that's one of the reasons I share my screen when I host these meetings is I don't want to
While
lose
you're
track of where I am.
Right.
pulling
So this is what your data sources, I think. Let's see here, data sources. So, all right. So CVEs are the most common public way to ID vulnerabilities. Yeah, they're not.
So this CVEs are issued. I would typically, at least I'm not really into security the way that you are, David, but they're issued on a particular package, right? Like
No.
it's no.
No. No. They are issued on a particular program.
Okay.
They may actually be issued on a. Let's see here. Each one is for a particular program or highly related set of programs. So let me give you an example of the relation. Sometimes what happens is somebody, say Intel, says, "Hey everybody, when you want to access this particular feature, here's the code to do it." And once again, their example was short because it was insecure. Everybody copied and pasted just like you would expect them to do, and so a CVE can actually be issued for many programs if they share something in common. But if they try to not do that unless there's some obvious commonality of the source of the code.
So if I'm taking Sophia's perspective of wanting to see the tree for a particular project, that's going to light up as a node. If I'm interested in vulnerabilities, there's going to be an edge to that node that says you're vulnerable here. You have a security
a little
vulnerability
marker.
here.
Means if you think of the nodes as a library, then suddenly there's a marker that says, "Oops, you have a vulnerability now."
Yeah, and I think Mariner, it looks like they wait. I don't know, I haven't looked at it, but it looks like waiting is the thing there. I mean, certain kinds of dependencies or things about dependencies might be of greater interest to me, and some different ones might be of greater interest to Sophia.
Yeah, I'm kind of curious what Sophia, if you can see these maps, what are the risk-related items that, like, if you could filter, that you'd be like, that's super helpful.
I guess it's also like, if you're mapping it out and you identify a vulnerability, you see all the things that it interacts with. So there's two paths forward. There's either addressing the vulnerability in the root, or there's finding a way to build around it and take it out of your project entirely. So obviously one is a lot more painful potentially, but if you map it out, you can make that assessment. If you only have one connection to that vulnerability or that hotspot, then maybe you choose to write it out of your program. If you have 20, then maybe you focus on fixing it. And so it's not, when you're thinking about risk, it gives you the way to assess how you address it. And risk, not just from the perspective of what's going to go down, but what is more costly to fix, and how do you move beyond it without being subject to that. I guess that's the first thing that comes to mind. Sorry, my cat is also having a tantrum again outside. I don't know if you can hear it, but.
Who is?
Can't.
Your cat?
Her cat.
Oh.
I let him in last call, but he kept terrorizing my mailbox, so he's outside again.
Yeah. Well, you gotta do what you gotta do. What is the cost of mitigating some identified risks to a project emerging from dependencies? Basically, is what I hear you saying.
Yeah, and it could also depend on the nature of the project. Like I guess the hope is that everything is touching open source. So you that implies you have more ability to either suggest, fix, or like address the root problem. But if you're identifying vulnerabilities or dependencies on things that are not open source, then there's now another element of dependency where you have to rely on someone else to fix it. So again, like how you think about addressing or removing it, that's another consideration.
Yeah, I mean, I put a note up under goals because I think that's a goal. It may be a question, but
yeah. I mean, I think this is also like where my brain always goes, but it's also just, again, like the nature of how you've built your thing, and visualizing it can also, like, you can reduce risk and dependency by the nature of how you build your application or your program or your piece of software, in terms of how you choose to build on top versus building in modules and providing connection points. And so you can try to isolate yourself as much as possible from any sort of shared risk or shared vulnerability across your entire program, so that when you hit run, then maybe only pieces will run versus taking everything down. And so, like, where I'm not quite sure if this would come up in a network analysis, this maybe comes up in your service architecture view of what is required in order for you to run successfully. And have you been able to successfully compartmentalize problem areas such that it reduces the risk of the entire thing not running. But that's more about, I guess, like how you design and build something, not how you retroactively try to fix your dependencies. So I don't want to get too much into how we consult on architecture.
I put that under, I think the service architecture perspective would go under like a runtime category of dependencies. That, how have I modularized my software? So, like, because basically if you're just making an API call, the vulnerability is probably low, unless there's a quality of data or financial transaction or private transaction involved.
Yeah, but I think what you're talking about is more about rating the like sort of the impact of what that is to your system. Like, is it, are we just like, are we missing data, or are we unable to complete a payment? And I think one is a lot more severe. So if we're thinking about it as part of the risk, and I guess we're in the risk working group, then there is a weighting component. So knowing that dependencies that are tied to sensitive areas are potentially more problematic.
Folks, we are at time.
Yep, we are.
Oh, I had a crazy not part of this topic.
Go for it. Hit us with the crazy at the very end here.
I'm spilling the beans, so you can't tell anyone yet, because that's going to be the presentation.
Want me to stop recording?
Yeah. All right, so that concludes this.